Welcome everyone for the second attempt of live streaming, a final summary and conclusion update of Clang versus GCC. Clang, actually a full GNU-less system, not only Clang, LLVM Clang and Musl system libc versus old established GNU glibc stuff. And raise your hand who finds it ironic that the only thing really currently that fails here, Pulse Audio, can't make this up. 2019, the year of desktop Linux, and the only thing that doesn't really reliably work is Pulse Audio. You can be happy that I'm not using systemd, because otherwise we would have even more problems of that sort. Delete failed video. I hope that's the right one. So yeah, final update. I hope this time with audio. Actually, I probably should double check that yet again, although the VU meter is moving here. So yeah, what have we done? The last also, don't need to show that. So the final update, if you're interested in all the details, we had dozens of videos there previous months. First getting a Musl system built, then getting a GCC lib system built, and for all the Debian people who recurrently tell me that it's totally no work, plenty of days, nights, traveling, flights, sitting on the balcony beach, probably in total 100 hours easily gone. And although I tweaked and packaged a lot of this stuff, because believe me, it just doesn't build by itself, you can try. A lot of this stuff is actually in T2, our unsuccessful one-man distribution source stuff. There you can, for the most part, actually build it, except some bootstrapping enablement, mostly actually CRT begin and end stuff. And yeah, need to take a look on this another day. Anyway, so the summary, the big summary for this is that all of those, or not all, most of those values here that you see, at least in terms of build size, because so build size is that. And what this is not only as per the previous videos, we benchmarked here also tiny c, and so TCC, PCC, NV, and WCC, just to get an understanding what modern compilers, how slow they became, and what kind of build times we would have for some really blazingly fast compilers. So yeah, but for that, previous videos. The Clang benchmarks here, at least for the build time. So you see Clang, as per the previous videos, was much slower than GCC, and I didn't really quite get why. And this was mostly because my system was defaulting to size optimization. I uncovered this in another video. I benchmarked this a decade ago, but it turns out nowadays with all the STL, standard template library based generic code, this kind of optimizations actually hurt the runtime quite a bit. So that is why the build time, because Clang itself was built with size optimization, right? So this is why all the previous benchmarks here have been slightly skewed and slightly unfair in regards to Clang. And I now rebuilt here two results today. So a couple of notes here, a little bit of intern stuff along the lines. I actually totally destroyed my virtual machine, and with updating this, so mostly also with link time optimizations. Actually, I do not really quite understand which of those steps totally broke my system. I basically at the end spending there, you see I spent 4 or 5 hours in the night and stuff, and at the end of the night my whole virtual machine was totally kaput. I think probably building LLVM Clang with link time optimizations had a great part in that, because that consumed quite some memory, 4 GB per process, and then some of these optimizations, because Clang LLVM builds quite some binaries at the end, like LLVM -AR for archiver, object dump and whatnot, and table gen and whatnot. And also Clang, like Clang, actually we can take a look at this. So that would be all in user bin Clang here, all those binaries, and Clang LLVM. And actually we can take a look how, actually no, so they are not link time optimized, no. So all of those binaries, you see they become rather large. Let's take a final look here at Clang. Again, more detail. Clang 9, obviously. And yeah, so this is, for example, 60. So you see that the old ceiling was also shared yeah, that's also a great part. So as per the previous videos, if you're interested in all those details, probably want to watch all of them. You see, after spending quite some hours, you start to forget some details. Another large part actually was also having this shared object. As you see, the previous ceiling 8 was just 104K, and the rest was all the code living in the shared object. It's obviously quite crazy, right? Just a tiny shell of the driver, the front-end driver, and all the rest of 64 megabytes then split into the shared libraries. And I changed this now, also mostly because it didn't even build anymore with shared objects. And now you see the ceiling binary is 64 megabyte. However, this is more compact than all the shared objects are together. And as per my previous video, that greatly speeds up the ceiling compiler. And now as per the results here, so all the old ceiling results are ceiling itself size optimized and linked to shared objects. And all those results are old, except here the version 9 optimized v90. And here we can compare this again. Previously we have only seen this with a Linux kernel, which obviously took forever, like 26 minutes versus 16 and 10 minutes and stuff. And previous video for details. But here we see this again. So this is build time. This is a previous, just as a final conclusion for the whole system benchmarking here. Previous version 8, size optimized and shared library linked. And you see here more than twice as fast here for the new version 9. The version probably only very tiny amount, but building all of this takes hours, right? So, and beside, I destroyed my virtual machine totally trying to link time optimize it with it. And although not all of this is twice as fast, GNU PG but it's nearly twice as fast, just not quite there. Also gzip not twice, but nearly. So everything a great deal faster. And if you compare this makes here a build time relevant, because this is of course quite a different system load. If we compare this, because these are open bench like spec like benchmarks, of course the runtime, the final runtime of the produced binary, which is like bzip2, gzip and stuff, is similar. So here we see actually this is purely the difference between version 8 and version 9. So there you have it. It became sometimes a little bit faster, couple of actually sometimes quite a little bit, but certainly not a great magnitude of difference, as we see on the other side running ceiling itself. And yeah, it became a little bit faster, but just set standard. Not so. There you see quite some benchmarks can become a little bit faster, but then just one benchmark not. I have also the number for 03, so this is 03 if you're interested. So but here we need to be careful, because due to the alphabetical sorting, this is 03. Wait a second, or maybe it didn't. Oh, wait a second, I didn't have the Musl. You see all the different non-Musl, glibc, and all the different flavors. The table becomes quite large here. But here we can compare 02 versus 03, which actually is, if I didn't miss it here, I know it's a tiny little bit, 30.32, a tiny little bit, just my usual expectations here, actually slightly slower. But anyway, that was not the big conclusion. The big conclusion is the massive code base that is ceiling doesn't like size optimization. And certainly if this is your system compiler, that is twice as slow, and there you see, or more, for the Linux kernel it was more than twice as slow, and there a plus shared library object. I didn't even expect this. So many details learned here on this journey, and at least I can now be more confident if we compare this here to GCC 02. That was 158, and now this is for a non-GNU system. Is here one, wait a second. This could actually be now much faster if we didn't miss here some lines. So 02 Musl, so maybe this actually really is much faster now in this combination. Finally, just, well, not too much, just a tiny little bit, 02, 193, a little bit hard to compare just this. Actually here, this is libmet not faster. Set standard was 14, so now this actually makes it certainly much more sense. And a huge lesson learned for me is not only the C++ template-based code optimization for size versus speed and such, because historically, a decade ago, size optimization was often a similar speed, if not slightly faster, especially on lower end CPUs due to cache size optimization. But the much larger impact is this shared objects with the dynamic linker. We certainly can take a closer look another day in more detail, but intuitively, well, again, intuitively often wrong, but intuitively I would say this is due to not only the shared objects being larger, having all the code that is not used, so this performs some kind of all the symbols for whatever algorithms not being used in sealing when used with LLVM, but the much greater part also relocation, because all the jumps and symbols need to be relocated dynamically for whatever combination this program uses, because this cannot be done well. Previously there was some pre-binding or whatever that was called but I think that's mostly not used anymore, deprecated, bitrot and whatever. I guess pre-binding was a huge thing, whatever that was called. I think it was pre-binding decades ago, but this was actually pre-computing symbol addresses for all kinds of combinations of system libraries. I actually expected this not to have such an impact anymore, but apparently it has a huge impact, at least for symbol-laden, huge, monstrous C binaries as seen here. And with this kind of result, we can actually compare here at least GCC 03 also for final look. So this indeed for the build time. Build time for me relevant because I certainly compiled quite a lot of stuff, and also due to that quite nice stress test as we have seen for the compiler and such. So here 2 seconds. Again, this bzip2 code base is small. Why do I even use this benchmark? So this benchmarks run 2 seconds and fractions of a second, but on an Octane and P3 and stuff, such benchmarks still run 20 seconds or such if they are not such a massive Ryzen. So yeah, this is faster. This is also just a little bit faster. And yeah, so this is actually much faster. Also runtime for the binary 03, so 35. Actually, this is nowhere in this. So many rows, actually hard. So similar speed. So sealing is, for the most part, I would say, optimizing similar actually here, 18 seconds. So GCC runtime 18 seconds versus 14. So GNU-PG actually really faster. gzip not lame, 12 versus, well, at least it's similar. It's at 0.1 seconds, so 1/10 of a second slower, not too much of a deal. libmet nearly identical to 39 versus 240, probably in the margin of error here. Set standard, yeah. There we have it. So many details learned. If you have any audio render error, please restart your computer. Seriously, can't mix this up. Are you kidding me? But I'm pretty confident that we have audio now. Yeah, but this is whatever Chromium. Thanks for that. You can actually reload the site. I hope you learned something. The only thing is, given the fully automation, why is this fully audio running error? Yeah, 0 drop frames. I hope that video had audio. At least my view meter is moving and nobody complained. It's hilarious. Certainly shouldn't have updated Pulse Audio earlier this morning in T2, the fun stuff of open source distribution. And the only big drawback is right now, besides that quite some stuff is not yet building, right? So actually I could have checked in here on my data center, which I don't really feel like logging in now live. Probably don't have, or do I have many of my, so many there or there, and this is OBS or here, or this also not, maybe that is local, but probably not. And the biggest drawback is actually right now that some stuff doesn't build. So for the ThinkPad, actually I have a partition here with this Musl build installed from the other months, but I couldn't even get Qt to build with some, even the relative early in the build it says can't detect thread model something, whatever. And there you see modern build systems. I was poking around there for 25 minutes and didn't even quite get where it's trying to detect the thread model. Usually I would like try to hotfix this, like hard code something, but didn't even find the code snippet in this QMake whatever stuff in Qt. So amazing build systems in 2019. But even then, not even Qt, even quite some other stuff, even small stuff like PPP, not that anyone would still use this point-to-point tunneling protocol stuff, but I think even there something didn't build. That I might have already hard-coded out for now, some of this old-fashioned protocol, whatever stuff, because in Musl they don't have all this old compatibility stuff, so even there, beside Qt, it's certainly a huge number of packages, but even all the small stuff, I already patched quite a number of those, but there's still so much to go. The really biggest drawback, all the small stuff, well, the biggest certainly Qt if we want to live stream with OBS, but the really biggest showstopper is right now that the totally small silly part, the runtime CRT stuff, I actually can show you that because I started a new build. So this is a new full build here, and maybe also new mount proc def because this was change rooted in that. And I started a new build in, not build in Musl, something new. And I knew this, so I knew because the last time I spent hours at midnight tinkering around in it and patching and debugging and stuff. And there is some kind of loop dependency for the CRT stuff that besides this is not even like really officially packaged. I only was lucky to get something to work. This is in, I think, compiler runtime of LLVM and name, and it builds something here in this CRT begin and stuff. And this is only because I spent already hours of packaging and bit fiddling the stuff here. And wait a second, where are those from? Anyway, this strange thing is, I think the problem is on a glibc based system. They are in glibc, I think. Let's check CRT, also best with no typo, CRT or ADMF list. I guess they are mostly in glibc. Actually, I saw some already. Let's just glibc here. Yeah, so I think they are those. I just wonder why did we... These are the startup files. Actually, I just wonder why we have here some actually surprisingly in... Where did those came from? They are not even archived. Why are that? Maybe some cross built-in toolchain placed them there. That is strange. Actually, we could check log. Anyway, the problem is, I also wonder that they historically did not really come with a compiler. These are the startup files of the C runtime, and you see Clang installs here some, but not all, and I do not even quite remember. This was such strange chaos. I'm actually not even sure if they are, maybe I even added them to compiler RT, not ARM, develop, compiler RT, yeah, right, I think, now that I think about this, somewhere, but it's not here, interesting, somewhere I had, I patched in some download actually from, anyway, you see so many details, and yeah, such a tiny detail, and it's a little bit of a surprise that this was in glibc and not GCC, and somehow the LLVM upstream people don't really have a replacement. There is something in compiler RT, and Maybe I accidentally deleted it then. Where else could that be? CRT in any of those disk. Wherever, I need to look this up. And the last time I only patched and clobbered that together in some night, and eventually I was actually surprised that it worked. That is, actually it would be more interesting, for me anyway, it would be more interesting if I deleted this something. We can actually check in compiler RT-svn log. What did I remove superfluous? Yeah, actually I have the feeling that might have been that one. So much to prematurely. I'm pretty sure that is some CRT stuff that I patched in there. Anyway, so much research, and their days and weekends go by with just those details. As per usual, was it really worth to do that? You might ask, maybe not. Wait a second, this is even a pre-release. Wait a second, somehow this... you know what, I actually... SED defect here, this download URL also. Yeah, was it really worth it, given this time went in there? And this is also the same with earning money with Simple30. Exactly this is what I was looking so much to my memory. So many details, and then even so many details I start to forget those details anyway. Yes, this is exactly that. CLang relies on existing certain symbols that are normally provided by CT-begin, CT-end. However, LLVM does not currently provide those implementation, and yeah, I need to check these details so much to accidentally remove some patch that was not yet to remove. Was it really worth it? Given that I spent way too many hours on this GCC-less system? Maybe not. Especially as we are not finally there at right? Qt, whatever, all the other, certainly you can't neither build Firefox nor OpenOffice with that or LibreOffice, and not even Qt. Although in others, what is it, Alpine or wherever, or even maybe Clear Linux, they somehow built it, but then this stuff also sometimes either builds accidentally or because they in Clear Linux or Alpine Linux or wherever work around with other stuff. So maybe it wasn't really worth it, especially as there's still such a mountain of work to do with these details. And the other thing is, of course, my grief that I already had with embedded projects a decade ago. It was always when we had projects and the people always complained that everything takes too long, although people around me usually were impressed what kind of magic I was typing there. And of course, we usually delivered in time, but sometimes not. And if you sometimes need like twice as long for some system enablement stuff for MIPS and ARM, and then people don't want to believe how much work that is. And then they even tell you, yeah, but this basic stuff needs to work in your Linux distribution, right? Yeah, it needs to work. So I need to spend 80 hours or 100 hours for this basic enablement stuff, and it needs to work, right? And nobody wants to pay for this basic stuff, which takes the most time, expected to just work. And everything a little bit hilarious in the open source landscape. Speaking of which, I checked, so Musl has theoretic support for MIPS64 for the Origin 2, or the 200, right? Or 2000, no, 200, I think 2000 was a supercomputer, or the SJ Octane. However, this is only release 6, so MIPS64R6. That only means latest and greatest embedded chips and processors and silicon. So it would be a fun live stream or video to try to run Musl MIPS64 on the SGI Octane or Origin 200. However, I have the feeling it will be similar, 80 hours or 100 hours of tinkering. And yeah, now I need to get back and actually revert this update stuff. And yeah, so much to that. I hope you learned something and found this interesting. But even, well, again, why did we do this? We would save quite some 50 or whatever, certainly install size, even more, maybe install size of GCC with all its stuff, 50 or even 100 megabyte. I don't know, we could actually, I can't maybe really check this because the size that is accounted here might be 2 versions. So actually a 512 megabytes, 3800 files on this virtual machine, but this for sure includes at least 2 versions. Actually, we can check this user. This should be somewhere in something of that sort. Yeah, okay, this is only 2 versions. So actually, if this megabytes, why is this? Because this is also on AMD 64, including 32 and 64-bit versions. So a lot of libraries twice, and then 2 versions. So, but yeah, maybe 250 megabyte, actually quite some savings, and then compressed on the ISO. Maybe this is actually quite some hefty binary chunks on the ISO. So yeah, but yeah, saving because we need it anyway, right? LLVM for Mesa 3D. But yeah, so much work. It's hilarious. Really wish a little bit stuff would work more. Anyway, what kind of stuff do you want to see? Would you be interested in this kind of systems? I think I run this kind of Clang Musl in one production VM for testing. I saw there are quite some errors coming up on boot. So even I think there was even some netlink communication with kernel error for loopback device, or I don't know, some funny stuff. So this kind of esoteric stuff might still not work, or intentionally not, because it's relying on old-fashioned deprecated up and down APIs. But leave me in the comments below, what are you most interested? MIP stuff, PowerPC stuff, Musl stuff, full system. And yeah, I need to continue. Why do I even spend the time now? Because I've just wanted to finish this kind of research and review here, also for myself. For Musl, the biggest showstopper, except this startup stuff, it can't be that each time I compile this, I need to manually fiddle around there with compiling their esoteric external Bugzilla patches. Obviously, this stuff needs to be 100% scripted and just built when we want to build it. But the Linux kernel we can also build now. We've done that the other day. The only stuff now, actually, we could, fun fact, try to do this live here. But for that, we for sure want to disable LTO again. That would be musl config LTO. And yes, you can do this in the config, but that is slightly faster for me. The last thing that is missing is grub2. And I have the feeling this will not build. With grub2, we very theoretically could actually publish an ISO image, and at least the regular Musl image I actually published. So if you're interested in a glibc-less system because you want Musl, then that is already ready for download. And you know what, this takes a second anyway. Let's make this verbose, and at least it looks more interesting. And next we will anyway automate building all this stuff. My next project will be, I had this actually a decade ago, but re-automate this. Maybe a little bit nicer to really automatically publish ISOs of all the architectures from ARM to RISC-V on a weekly basis, fully automated. And another automation project will be automating the updates. That's a regular small like GTK plus or G-object and all the Qt fun stuff. Yeah, this didn't build long. Cross-compile host, what? Why did this fail so much faster than the previous run? This was previously already actually running faster though. Cannot compile C program. What the heck? Let's just build some setups. Zip, okay, then zip. Wanted setlib, but whatever. That is building something, so that is interesting. Maybe we actually inject, I noticed many years ago, if you over-optimize grub2, it will not work, it will just not do anything. I think most likely because the use of SSE whatever or AVX instruction doesn't work. Maybe it does raise an exception there. Let's see what we find in the grub2. Now I have to, super clever to cancel the first one. This was TempFS, very clever. TempFS maybe also to be optimized to leave the error there with TempFS. But yeah, this esoteric using each and every GNU GCC feature, always those projects that do not just build. Rebuild everything, the flex that makes you both. Yeah, exactly. I actually rebuilt. Fun fact, I think the image on the data center that is in production, although it is size optimized, which I mostly run their web server and stuff, but that I rebuilt everything with LTO. So except I found actually a couple of packages didn't build with LTO, link time optimization, so much to that. We now in T2 for that I introduced a new flag, which is no LTO. And so that is also new, always the infrastructure enablement stuff, grub2 and that config log, I guess. And what would be the error? Let's see, what unsupported argument or whatever funny stuff. Because I think the last time I checked a month ago, grub2 started to build, but then failed with whatever. Segmentation fault, what the heck? Cannot run compiled C programs. That did not happen the last time we tried anything. Well, some of those seg faults are earlier from when my virtual machine was messed up, but it is slightly unexpected. Especially with all the other stuff. I even rebuilt that standard already. Let's go alternative and okay, bash is free. This is really strange. Anyway, yeah, the bootloader certainly the last missing piece for a full GNU-less systems. But again, I think most people, but leave me in the comments below, do you care? I don't really care about GNU or not GNU. I only care about the size saved, and you have seen maybe 250 megabyte. Certainly quite some, although most people will say that is nothing, even fits on your 386 hard drive. But for the ISO distribution size, actually this did no, wait a second, this bash also failed now. How did we, actually this is now slightly messed up, so much to that, so something really broke a little bit, but this is, wait a second, so this is, but why do our tests run? So something indeed broke here a little bit again. This is exactly the symptoms that I had when this was messed up. I thought it was link time optimizations, but this is now, no, I didn't build var adm log 5 GCC, no, not GCC. Slang, obviously. No, that does not have O2. Proxies. Simple hello world works though. What else do we? Was it FLT or was it something else? Error loading shared library, LIVMGM. We need, you know what is the difference? The difference is the linker. That is, let's see, maybe the linker is the problem because it's yeah, right, the difference if I don't enable LTO, maybe we use the bin utils linker, actually, maybe the linker is broken. That would explain why the previous VM totally crashed itself with non-working binaries. Yeah, so much to all the stuff just works. And I did nothing for 20 years. Thank you very much, friends and family at Debian there. Var adm log. So that would be in what we just built and didn't was bash, and that was stretch. So that is, no, this is also, but why did this fail then? Because this is not linker LD. This is only RT. Sometimes also the track pattern after 1 week uptime has some Is this a compiler RT runtime? Strange stuff. Ah, look at that. But okay. Which runtime is it using if not this then? You see, tiny details, nothing to say, just keep calm and carry on. I wonder what is, probably I LTO to something earlier, but LTO, yeah, so need to debug this. Did I rebuild compiler RT? Maybe this is actually, maybe because, no, I did, no, this, I completely resynced this from the other virtual machine. What is it, FLTO or something, IDM log, and also 5. Yeah, so that is FLTO. Let's see if that works in principle, and then I need to, yeah, best do a complete fresh build and figure out a way to completely automate this, because automation, and that also, we also need fuse. Actually, maybe we test this independently. Okay, that still works, and then that also still works. Okay, so the only thing is somewhat broken, but it should use the same runtime. I'm a little bit confused now, because I think it should use that strange stuff. We could actually, with either something like verbose whatever, yeah, LLD, so that is using, actually that is funny, why is this using LLVM Gold SO plugin? Interesting. GCC, where is the runtime thing? Yeah, but this is exactly the part of the runtime where the CRT stuff is missing. And yeah, would need to CRTI. Okay, so this is CRTIO with and clang RT CRT begin, and that is inserting what? S, so this is using S CRT10 CRT begin S, which actually we don't have others anyway, so this is actually a link to the other ones because I wanted to get this compiling anyway back in the day, because this is manually, so this build, as you see, with exactly this part being unclear and not upstream and everything, had to manually fill around there a little bit. So let's see, so this is that one, and the other one was probably, maybe and then it scrolls away, A little bit inconvenient to read like this. Should be somewhere here, right? Clang. Somewhere. That is why I usually have this in a log file and not to try to find it here. Clang CRT begin probably are here built-ins. Where's the first one? Here's built-ins, CRT end, CRTN. Anyway, something of that sort. One certainly, maybe even twice, or not matching CRT begin as, let's maybe for final. So that is somewhere really hard to spot on a glance. Why is this so hard to spot, or is it only in, or is it this one? built-ins end, maybe is here no begin or what, or is it built-ins, something is fishy here. Maybe they just changed their tiny little detail upstream anyway, and now this didn't match with anyway. Yeah, so this details still under investigation. Then hope you learned something. Leave me in the comments below. Are you looking forward to non-GNU stuff for some reason, or don't like the BSD or whatever the C-Lang LLVM license is? And what actually I'm really a little bit curious. I actually want to see this bash as a grub2 build. Maybe we develop, a little bit warm here with this slide. Develop C-Lang, so that should be in C-Lang parse config compiler RT. So we insert here something based on a lot of this or not this. RTlib, so I think this should be that one, right? Let's maybe see if what that is doing. This is only a quick hack, obviously, to test if we're getting it anyway. Again, I need to completely rebuild this and figure the CRT begin and stuff out there. Does it look better? Maybe already, huh? But also this only works by sheer luck and accident with all the messy symlinks and compatibility stuff and changes and whatnot. Yeah, I agree. The comments audience. I also think this doesn't match there anymore. Whatever broke there. It was working before I rebuilt with C-Lang Clang 9. So grub2 is starting to build. grub2 being special, it certainly grub2 has its own CRT begin and stuff there. Hey, this build. Wait a second. This was bash. Damn it. So much to doing this on. Let's hope we didn't build the bash. If we now miscompiled the bash, then everything is gone anyway. It's so much to building the right thing here. At least we tested that the compiler still is doing something now with that removed. Maybe they actually even messed up their use compiler RT stuff. Maybe they broke this in their amazing random changes. And at least we established, yeah, so the bash still works. This is change rooted in the sandbox, and bash, just rebuild bash still works. Let's see how far grub2 is going. And yeah, grub2 certainly has its own CRT stuff, C runtime stuff there for the EFI and BIOS stuff and so on. And all the other runtime stuff, memcopy and all this fun stuff, and maybe even math stuff, libm and so on, because certainly or boot environment and so on. So all the stuff is custom there. Most likely, and this is grub2 is special because it certainly compiles with freestanding and all the other custom runtime stuff and whatnot, and other module building and symbol trickery and whatnot, all the fun stuff they always do there. So let's see. Before, again, a month ago, it started to build. I think it either in the middle or end. I don't quite remember. Whenever it stopped, you see it tries to get somewhere. But so let's see. Are we so lucky that this, hey, I guess, to do for tomorrow, trying to build this and maybe build a full image. I think this is progress. I'm pretty sure it didn't do that before with, so yeah, also only live on this channel. Then the biggest part, except all the small parts where here and there is some small tool and well, Qt5, the biggest part, nearly only part, well, nearly on, shouldn't say, nearly only, and so all the small stuff that takes 90% of the time. The one big part, CRT stuff, and then the other cleaning up what I just edited there. This is only so messy because so not only for that, this is based on package. So if we are building compiler RT and libcxx because of all the chicken and egg stuff, then for those packages, for other packages, inject this standard lib to switch from GCC lib standard version 3 C++ to the LLVM based lib CXX package and ABA package and unwind as their plenty of packages that usually GCC ships, all of them, unwinding, built-ins, runtime, which is also in the libgcc, and then the C++ STL template library. This is why there is so much code trickery in here, and then also the chicken and egg not inject this if we don't have them yet for the compiler RT and libcxx package, and then cross-compiling, there's some extra guidance, and otherwise yeah, custom override here for OZ, as we found in another stream that OS is not optimizing as much in LLVM Clang. Actually, maybe mostly, now that I think about this exactly, maybe they figured themselves that C++ STL stuff needs more optimization. So yeah, fun stuff here. And I hope you learned something. We made so much progress. It's probably maybe the YouTube videos not even giving it enough justice here of all this hard work it is. I'm only filming 5% of all the midnights. Actually, maybe it would be more interesting to have the camera running whole midnight here and me getting drunk over fiddling around with it kind of stuff. But leave me in the comments below, maybe on the More Live channel, if you're interested in this kind of stuff, as soon as our More Live channel. Right now it's a little bit, not only is a More Live channel copyright strike by Apple for trying to comment their amazing live stream, amazing stuff, thanks for that. I'm not even sure if, so 90 days no live streaming on the More Live channel, that is certainly not cool. And due to, I asked Google, can they unlock this live streaming earlier than 90 days? They said no. I've also probably make a dedicated video about this nonsense. So Google said if I want this earlier than 90 days going live again on this More Live channel, I need to dispute this Apple copyright claim. So I did this, although I didn't really want this. With a fine print, if I do this, I claimed their fair use and commenting public available stuff. So let's see what's happening there. Somehow I have not the greatest hopes. And with the fine print, if I, by doing this, it could result in Google deleting the whole account there. I hope this is only that other channel and not this main channel. So if we are entirely disappearing, then thanks for that. Fun stuff in the web times nowadays. Anyway, I hope you learned something, and as soon as we have our More Live channel back, whatever developed there, I hope then we can do more of this in the other channel, because I have the feeling all this in-depth coding, tinkering, Linux work and whatnot is too boring for most people, and then they unsubscribe. So at least I hope you learned something and enjoyed this. And as always, leave me in the comments what you think, what is more graphically, visually pleasant to watch and whatnot. And have a good night or day, and I hope to see you soon for the next of this random tinkering and Linux live streaming to come.